Okay, these are all the topics that I'm going to cover today. Okay, let's start with topic number 1, which is graphing exponential functions. Graph f of x equals 2 to the power of x. The most common points to use, or x values to use, is always from -2 to 3 or from -3 to 2. Okay, these are the most common ones to use, and right now you're going to understand why. So let's do a little table. Okay, let's put all the values there for x. So when x is -2, that means that we're going to plug in -2 where the x is the exponent. So it'll be 2 to a negative second power. We apply the rule, so this becomes 1/4. Or you can plug in the calculator, guys, 2 to a negative second power, and it'll give you 1/4. So when x is -2, y is 1/4. Now let's evaluate f of -1. When we evaluate f, 2 to the negative first power, is going to give us 1/2. So when x is -1, y is 1/2. Now let's evaluate it at 0, f of 0. So f of 0 is equal to 2 to a 0 power, and anything to a 0 power is always 1. So when x is 0, y is 1. Now let's evaluate f of 1, which means 2 to the first power will give us 2. F of 2 means 2 to the second power will give us 4. And finally, f of 3, we're going to evaluate f of 3 means 2 to the third power will give us 8. So then these are all my points: -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. And there's my graph. If you notice, here at -2, right? At -2, that means that I'm going to cut this unit into 4 parts, so this is about 1/4. At -1, we're going to cut it into 2 parts, it'll be 1/2. At 0 is going to be 1. At 1 is going to be 2. At 2 is going to be 4. And at 3 will be 8. That's why we only choose these values for x, because it'll be useless to use 2 to -3, because -3 will be here, right? Eventually, the more negative that you get, it's going to get closer and closer to 0, but it will never touch 0. So all these points to use are not required, because eventually they're going to be useless. And going to the right, if we pick 4, 2 to the fourth power will give us 16. 16 will be way up here, will be off the grid. So these are the most common points to use, and we can adjust depending on the base. In this case, base is 2, so we're okay with that. Now let's graph 2 to the x minus 1. You see, let's use the same points for x. Right, so when x is -2, right? So it's going to give us -2 minus 1 will give us -3, so it's going to be 1/8. And when it's -1, it's going to be -1 minus 1 will give us 2 to the negative second power, will give us 1/4. When it's 0, it'll be 2 to the 0 minus 1 will give us 2 to the negative first power, will give us 1/2. When it's 1, 2 to the 1 minus 1 will give us 0. 2 to the 0 power will give us 1. When it's 2, it will be 2 to the second power minus 1 will give us 2 to the first power, will give us 2. And when it's 3, it will be 2 to the power of 3 minus 1 will give us 2 squared, will give us 4. And finally, when it's 4, will give us 2 to the power of 4 minus 1 will give us 2 to the third power, will give us 8. So the graph, I don't think I drew the graph here, but the graph, everything shifts 1 unit to the right. Remember the horizontal shifts? This means that it's going to be a horizontal shift. So all these points from the parent function moves 1 unit to the right. Okay. Now let's graph exponential functions. Continues, right? So let's try 2 to a negative x power. So in other words, 2 to a negative x is the same thing as g of x equals 1/2 to the x power, because these are equivalent. So again, right, by plugging the same points for x, now, right, let me do the first one, right? So if we plug in -3, right, you use a reciprocal and make it positive. So it's going to be 8. And we repeat the process all the way till 3. Right? So all these points, these will be my answers here, guys. So all these points, the graph starts high and it keeps going lower. The bigger it is. The bigger the x value. So anyway, guys, if it's 2 to a negative x, the graph reflects on the y-axis. Okay, because remember the original one, it went from it started low and it went up high. So this means reflection on the y-axis. Now, how do I apply them in real life? Okay, this is number 4. It says the assets in billions of dollars for a Prudential Financial Incorporated can be approximated by the function a of x equals to 315 e to the 0.056x, where x equals 7 corresponds to the year 2007. Find the assets for the following years, for the year 2000 and for the year 2012. Solution, right? So if x equals 7 corresponds to the year 2007, then the year 2000, x equals 0 corresponds to the year 2000, and x equals 12 corresponds to the year 2012. So for A part, we're going to evaluate A of 0, which means I'm going to plug in 0 for the x's. So this will give us 315 e to a 0 power, and anything to a 0 power will give us 1. So 315 times 1 will give us 315. So the solution will be 315 billion because the assets are in billions of dollars. Okay, now it's good to know that 315 is the initial value because the time is 0. When time is 0, whatever the number is here, that's going to be your initial value. This is crucial for the next problem that we're going to be doing. But let's do B now. B, we're going to evaluate A of 12, which means I'm going to plug in 12 for the x's, and then just use your calculator. Okay, make sure that then the calculator, guys, this is a form, because there's a lot of mistakes that students make because some calculators if you raise the e to the 0.056 times 12, most of the times it's going to give you e to the 0.0556 and then times 12, which is wrong. It has to be in this form with parentheses. So make sure that you enter it correctly. And this is your answer, guys. So it's going to give you something like $616.8 billion. Okay, now this is number 5. This particular problem, guys, I got it during the pandemic of COVID back in the year 2000. I believe right before we went on break, the exam 2 was administered on that week, on the 8th week. So anyway, I used the info that was given from the current news, and I used this example to teach students how exponential functions work and how we can come up with a function given 2 points. Okay, so here's our problem, number 5. A deadly virus has infected the world. At the end of January, there were 2 cases, and by the end of April, the cases had grown to 128. For A part, find a model of the form f of t equals to y naught b to the t power, with t equals 0 corresponding to the end of the month of January. Remember, guys, from the previous slide, t equals 0 means that whatever the value is when t equals 0, that's your initial value. In this case, I think it's going to be 2, because 2 cases at the end of January. And then for B part, if the trend continues, about how many people will be infected by the end of the year. Okay, so let's find first part A. Need to know y naught and B. The y naught, guys, is the initial value. The initial value is when time equals 0, so the answer will be 2 for that one. Right, so y naught is 2. Now to find B, right, we go from the end of January to the end of April. So it's going to be 3, I believe. You see, so I did all this so it can be visual, so you guys can know that the next point is going to be 3, 128. Right? You see, so when x is 3 is 128. Maybe I should have put the point there. That will be more visual. But anyway, guys, the second point is 3, 128. So when t is 3, there were 128 cases. So from here, we're going to plug it into the formula. we already know what y naught is, which is 2. Right? We're going to plug in f of t, right? This means when t is 3, this is a result, which is 128. So 128 equals 2b to the third power. Now, with the given info, we need to solve for b. So we start by dividing both sides by 2. So it's going to give us 64 equals b cubed. Then to solve for b, we're going to raise both sides to the 1/3 power. Right here, the b to the third to the 1/3 power. This we apply the power rule. When you have an exponent raised to an exponent, you multiply the powers. So 3 times 1/3 will give us 1. That's why this will become 1. So 64 to the 1/3 power is 4. So b is equal to 4. So I have my y naught and I have my b. Plug them into the formula. So this is the answer for A. F of t equals 2 times 4 to the power of t. This is my y naught and b. Now for B part, right, from January to December is 11 months. Right, because it says by the end of January to the end of December is going to be 11 months. So we're going to evaluate the function in part A. We're going to evaluate f of 11 for part B. So all we do is put in the calculator. So it's going to be 2 parentheses 4 to the 11th power will give us 8,388,608 people would be infected by the end of the year. This will be, but this wasn't the case in the U.S. There was a lot less. Why? Because we did interventions. For example, it was social distance. We had to wear masks. We have to wash our hands and all that stuff, right? That we intervene as a country. But say that let nature take its course. This will be like an estimate, more or less. This will be accurate. Okay. But this is how trauma students how to apply exponential functions in real life. Number 6, solving exponential equations. So here's the rule or the definition. Let A be a positive real number with A cannot equal to 1. If the base A to the U equals to the base A to the V, then if you have the same bases, then the exponents must equal to each other. Example, but here we have the same bases, right? So x equals to 5. We apply the rule. Now let's solve number 6. Solve for x. We have 125 to the power of x equals 5 to the 5th power. So these are not the same bases, right? So we cannot apply the rule. So let's do this. 125 is equal to 5 cubed, right? Because we try to see if 5 is the lowest base for both of them. So we know that 125 equals 5 cubed. So I'm going to substitute 5 cubed for 125. Then we're going to apply the exponent power rule. When we have a power to a power, we multiply the powers. Now we can apply the rule. Why? Because now we got the same base. So we let the exponents equal to each other. We divide by 3. So x equals to 5 over 3. And all these problems, they can be checked. Okay? Right? We plug in 5/3 for the power of x. You can put that in the calculator, guys, and it's going to give you both answers will be the same. Okay, so we know these two are, we know that's the correct answer. Okay. Now let's solve number 7 here. It says 4 to the x minus 1 equals 32. So let's see if 4 is a common base of 4 and 32. Let's raise 4 to the 2nd power. Is not equal to 32, so that's not it. Let's raise it to the 3rd power. It's over, right? It's 64, and 64 is more than 32. So let's see if we can find a common base. I believe it's going to be 2. Right? Because 4 is 2 squared, and 32 will give us 2 to the 5th power. So we found the common base. So I'm going to plug in, substitute 2 squared for 4. And I'm going to substitute 2 to the 5th power for 32. Now on the left side, we apply the exponent power rule. Right, so when you have a power, you multiply the powers. So now we got the same base, so we let the exponents equal to each other. We can apply the rule. We distribute. So give us 2x minus 2 equals 5. We add 2 to both sides. And then we divide by 2. X equals 7 over 2. And again, you can always check your work. So I'm going to plug in 7 over 2 where the x is. 7 halves minus 1 will give us 5 over 2. And you put that in the calculator, guys, 4 to the 5 has power is going to give us 32. So we know that's a correct answer. Okay, now this is writing exponential equations into logarithmic equations and vice versa. Okay, so let's do this is the definition. If you have y equals to log base a x, means that a to the y equals x. So here, guys, on the left side is exponential form. On the right side, on the left side is logarithmic form, and on the right side is exponential form. Write each logarithmic equation into exponential equation. So here, guys, we have to know what the a is, what the x is, and what the y is. So in this case, my a is equal to 9. My x is 81, and my y is 2. Then I go to the equivalent formula from log to exponential. So we got my a is 9, my y is 2, and my x is 81. So this is the answer, guys. This is equivalent. So the answer will be 9 squared equals 81. Write each exponential equation into logarithmic form. Now we're going the other way. We're going from exponential to logarithmic. Again, we have to know what the a and what the y and what the x is. My a is 5. My x is my y is 3. My x is 125. Now we go back and plug in the value for y is 3. My base is my a is 5 and my x is 125. So this is your result. 3 equals to log a base 5 of 125, or you can rewrite it as log a base 5 of 125 equals 3. These two are the same answers. Now let's graph logarithmic functions. Okay, in order to graph without a calculator, must convert logarithmic equation into an exponential equation. Okay, example. Remember, y equals to log a base ax equals to a to the y equals b. A to the y equals x. Number 10, you're going to graph y equals to log a base 2 of x. This is equivalent to 2 to the y power equals x. So here, guys, instead of plugging the values for x, we're going to plug them in for y. Okay, and like before, if we plug in negative 2 for the y, is going to give us 1/4. Right, and if we continue in the same process, these are my results. Right, if I plug in negative 1, it's going to be 1/2. If I plug in 0, 2 to the 0 power is going to give us 1. If I plug in 1, 2 to the first power will give us 2. If I plug in 2, 2 to the second power will give us 4. If I plug in 3, 2 to the third power will give us 8. And the graph, right? I didn't graph it here, guys, but this is I graph it both. This is the y equals to 2 to the x, and this is in red is the log function. In other words, these two are inverse of each other. But I believe in this class, I believe we don't cover inverses in 1324. Okay, but this will be good for 1314. But anyway, guys, these are the two equivalent. This is the log in red, and this is the exponential in blue. Okay. Now expand or condense logarithmic expressions. So we have to know some of the properties. For example, property number 1 is called a product rule. When you have the left side is condensed and the right side is expanded. And here are the properties: product property, quotient property, and power property. They also work the same thing for the natural logs, for the ln. Okay, now let's review the properties real quick. Right, if you have log a base a of x times y, we separate them and it becomes addition. If you have log a base a of x divided by y, when the quotient will be subtraction. And the power rule, if you notice, the power comes to the front. Okay. Again, this is condensed and expanded. Okay, let's expand this one here. Which properties are present? If we notice, we have the product property, right? Because we're multiplying, and the power. We have 1 and 3, product and power. We need to add 3 separate log terms, right? Because remember, here there's 2 variables, right? So we have two log terms. Now here we have a number of 5 and 2 variables, so it's going to be 3 log terms. There's 1, there's 2, there's the other one, right? Now remember, guys, right? So we want to expand it. When you expand them, there's no exponents. So then the exponents go to the front. The 4 goes to the front, and the 3 goes to the front. And this is my expression already simplified. Okay, let's do another one, but I believe now we're going to go the other way. No, it's the same one, okay? So here, guys, right, we have all 3 powers, all 3 rules here. We have multiplication, which will be addition. We have division, will be subtraction. We have the power, the exponent rule. You see all 3 of them are present. All right, so first, right, we're going to apply the quotient rule. So we have numerator, right? Like up here, we have numerator and denominator. The numerator will be positive, and the denominator will be negative. So it's going to be a minus. Also, if you notice, we don't have a log there. If there's no log, it's going to be base 10. Okay? But we just leave it with no log because we know it's a rule that if there's no log, it's base 10. And then we're going to apply the product rule here. Execute the product rule. So here, right, so it's going to be log of x plus log of y squared minus log of w. Now the exponent must go to the front. So we're going to execute the power property. So the 2 will go to the front. And this is the simplified version of the expression, simplified expression of log x y squared divided by w. So this is your solution here, guys. Okay, now we have one more here. Now we're going to go, I believe, the other way. Now they're expanded, right? Now they're in this form. We have to condense them. So first of all, right, here we have subtraction. It's going to be the quotient property, subtraction. And we have a number in front of the ln, so we're going to have the power property also. So first, right? So first we can send the power to the front, right? The 2 goes to the power. Now we're going to execute the quotient rule. We have subtraction is going to be division under one log. This is your solution. Now we're solving logarithmic equations. Okay, again, same property, we're going to need them. So solve 6 to the x power equals 72. I said solve by using the power property of natural logarithms. So here, guys, we're going to take the natural log of both sides. We've done the exponent by taking the natural log of both sides. By rule number 3, the exponent goes to the front. Now we divide both sides by the ln of 6. We enter the calculator. So x equals approximately 2.38685280.7 at times. On the homework, Pearson or My Math app, they want you to round off to 3 or 4 places. So make sure that you follow the instructions how to round it off. Here, guys, it was 4 places. So if it's 4 places, right, you're going to go to the 5th one. We have 1, 2, 3, 4, right? We go to the 5th one. If the 5th place is 5 or more, you add 1 to the 4th place, to the decimal on the 4th place, which will be 8, right? So we're going to add 1 to 8. That way it's 9. Okay, now, very important about natural logs or logarithm, or logs themselves. The natural log of a number is actually a value. You cannot separate them, right? So, like for example, the ln of 6 is a number. The ln of 72 is a number. It's a value. You cannot say you divide by ln on both sides here. For example, these do not cancel, right? Because you cannot do that. These are two values. You cannot say it'll be 72 divided by 6 because these two are two complete values for the numerator and the denominator. Okay, now let's solve number 15. Okay, now it says here, let u and v and a be positive real numbers with a cannot equal to 1. If log of base a u equals to log of base a v, then u must equal to v. If you have the same logs with the same base, then whatever's in the whatever the u and the v is, so you let them equal to each other. For example, but they have to be one single log on both sides of the equal sign. For number 15, it's not the case. The right side is not a single log. Okay, so we have to apply the rules on the right side. So subtraction means, right, the quotient rule. It means division. So log of, right, there's no base, right, so we know it's base 10. Right, so now we have a single log on both sides, and they're both base 10. So by applying the rule, it's going to be x equals to x plus 3 divided by x minus 1. Now here, guys, we can cross multiply. For example, there's like an invisible 1 on the bottom, right? Like it's x divided by 1. So we're going to multiply x times x minus 1 and 1 times x plus 3. We distribute. So we get x squared minus x equals to x plus 3. Since we have a squared, something to the second power, we're going to send all the terms in the right side to the left side by subtracting x and subtracting 3 to both sides. This gives us, on the right side, it's going to be 0. On the left side, it's going to be x squared minus 2x minus 3 equals 0. Now we need to factor. Factoring, right? The sign here tells us that the signs are going to be different, right? The constant term signs means that signs are going to be different. So this one, we bring it down. And then we get the factors of 3. How can we get 3? It's only 1 times 3, and then we subtract them. So these are the factors. Okay, so then we let them equal to 0. So we get x equals to 3 and x equals to negative 1. Now we get to check our work. One thing that you gotta remember, the logs cannot be negative, right? For example, if we plug in negative 1 for every x, on the left side, right, this is undefined, and also the last one. So this is not defined, so that means they cannot be the solution. So let's plug in the 3. We plug in 3 for all the x's. Because here, guys, right, you can use a calculator if you want, right? And so this is the answer. So the answer is 3, or you can use the rules that we know, right? If we're subtracting, right, we're going to condense it, and it's going to be division. 6 divided by 2 is 3, right? So you see, we know it's the same value. Log of 3, log of base 10, 3 equals to log of base 10, 3. So we know 3 is a solution. Okay, let's try one more. Now there's another rule. If you have a raised to the power of log of base au, right, is equal to u. So how do we use this rule or this property on number 16? Okay, we want to cancel the log of base 4. So we're gonna make the left and the right side be the exponent, and the base will be 4. Right? So this will be the exponent, and we have the same base, right? This way, we apply the rule, and it's equal to 5x plus 6 on the left side. Now 4 squared is 16. We subtract 6 from both sides. We divide both sides by 5, and the answer is 2. I'm sorry, I was thinking about the answer. And the answer is 2. And again, you can always check your work. right? So we plug in 2 for x, it's going to give us log of 4, 10 plus it will be 16, right? If you put that in the calculator by applying the change of base rule, it was going to give us 2. So 2 equals to 2, right? So we know that's the solution. And again, here we apply the change of base because this cannot be put in the calculator how it is because the calculator only takes base 10. So by apply the change of base, it's going to give us log of 16 divided by log of 4, and that will give you 2 on your calculator. Now we're doing the chapter 5, the simple interest problems. Here's where the finance section is. Gabriel invests his summer earnings of $3,000 in a savings account for college. The account pays 1.5% simple interest. What will be the value of this account after 2 years, and how much interest did he earn? So for simple interest, there's 2 formulas, okay? But let's apply this formula here, which is one of the 2. Okay, because the first part, we're looking for the future value, right? What will be the value after account after 2 years? So we're looking for the future value. So what he deposited or what he invested was 3,000. So that's my present value. My interest rate, which is the R, will be 1.5%. But we have to convert it to a decimal. So it's going to be 0.015. My T, let's see what it is 2 years. We plug him into the calculator, right? And it's going to give us 3,090. Now, to find the interest, right, how much interest did he earn? Interest is equal to the future value minus the present value. So the interest that Gabriel earned is 3,090 minus 3,000, which will be $90. So the value of the account after 2 years will be 3,090, and the interest earned will be $90. Here are the 2 answers for number 17. I believe number 18 is called compound interest. The compound interest is when you're going to deposit money only one time, and that's it. Just you're going to invest the money, or you can use it to if you have some money there in your house, right, and you want to invest it, you can do that. And all you do is invest that money without without additional payments or without additional money that you put in, just one time, and that's it. And then you wait a few years and see how much money you have. This is a formula that they use, right? But this is easier formula. These 2 formulas are equivalent. If you notice, the I is equal to R divided by M, and the N is equal to M times T. So the future value means the future or maturity value. The present value, the PV means principal or present value. The R is the interest rate in decimal. The M is number of compounded periods per year. The T is equal to number of years. The I is R divided by M, and the N is M times T. Now here are the key words for compounded. If it states yearly or annually on the word problem, M is equal to 1. If it states bi-yearly or semi-annually, M is equal to 2. Quarterly, M is equal to 4. Monthly is 12. Weekly is 52. What else? Daily is 365 or 360. It depends. If the book says 360, well, then you use 360, but most of the times it'll be 365. And continuous, it's a different formula. Okay? Again, compound interest can be used to invest a certain amount of money without depositing additional money. It's what I mentioned at the beginning of this slide here. So here we go. You deposit $9,000 in an account at your bank that pays 2.5% interest semi-annually. How much money will there be in the account after 10 years, and how much interest did you earn? Okay? So there's 7 variables that need to be accounted for. Okay, 1, 2, 3, 4, 5, 6, 7. So we're looking for the future value, right? Because it says how much money will be there after 10 years. That's in the future. So my PV, my present value, will be 9,000. My interest rate will be 2.5%. You have to convert it to a decimal. It's going to give us 0.025. My M is how many times it's compounded. It's compounded, let's see here, or semi-annually, which means 2. The time is 10 years. The I will be 0.025 divided by 2 will give us 0.0125. And the N will be M times T, 2 times 10. The answer is 20. Plug into the calculator. Plug everything in the formula and then in the calculator, and it's going to give us $11,538. And run that out to the nearest penny will be in 34 cents. So after 10 years, there will be $11,538.34 in the account. Now, how much of it was interest? Right, so the interest earned is equal to future value minus present value. The future value that you received was $11,538.34 minus what you invested, which is $9,000. So this comes out to $2,538.34. So that's how much interest was earned, $2,538.34. Now this is number 19. It's going to be future value of an ordinary annuity. Okay, this is number 19 on this presentation. At the end of each quarter, a 50-year-old woman puts $1,200 in a retirement account that pays 7.2% compounded quarterly. When she reaches 60, what will be the value in the account and how much interest will she earn? Okay, so for this is a different formula. This is for the future value of an annuity. Again, there's seven variables that you need to account for. Okay, let's read it correctly here. At the end of each quarter, right? 50-year-old woman puts in $1,200. So we're looking for what will be the value of the account and after she's 60, right? So we're looking for the future value. The payments that she's putting is $1,200. The interest rate is 7.2%, 0.072. Compounded quarterly. Quarterly means M is 4. The time, right here, the time. She started when she was 50, right? And she wants to when she reaches 60, right? So it will be it's a 10-year gap. So my T is 10. The I will be R divided by M, 0.072 divided by 4 will give us 0.018. And the N will give us 4, M times T will be 4 times 10 will give us 40. Let's plug everything in there. Right? So here I'm going to show you how to use in the calculator a TID3, TID4 without stopping. So first you're going to input the numerator, which is 1 parentheses 1 plus 0.018 close parentheses to the 40th power minus 1. And what's in black is what you should see on the screen. Then you're going to hit the division key, right? Because you're going to be dividing. Right, so division key, so you just see this on your screen, the answer divided by, then you're going to enter 0.018 and enter. This is what you should see on your screen. And after that, you're going to multiply that by 1,200. So the answer will be $69,421.34. That's how much will be there after 10 years when she's 60. Okay, now how much of it was interest? So how do we find that? How many payments did she make? She made 40 payments, right? Or 40. She put 40 times. She put in $1,200 in that span. So we're going to multiply the 40, the number of payments times the amount of the payment. So it will give us 48,000. So in other words, she only put in 48,000 out of her pocket. So it'll be 69,421.34 minus 48,000. So she earned $21,421.34 of interest. That's how much money she got extra. Okay. Now number 20. Present value of an ordinary annuity. And again, this is a different formula, okay, because this is present value of an ordinary annuity. This is used when you're going to purchase a car or an expensive item like a house. So this is a formula that we're going to be using. And again, there's 7 variables that we need to account for. So here it says you want to purchase a $325,000 house with a your fixed rate of 3.9% interest. What are your monthly payments and how much interest did you end up paying? Okay, so this is the money, right? So we're looking for the payment. So this is the money that you borrowed from the bank, which would be $325, because we're looking for the payments. The interest rate is 3.9%, which would be 0.039. My M right monthly means M is going to be 12. The time is 30 years. The I will be the R divided by M, 0.039 divided by 12 will give us 0.00325. And the end, the number of payments will be M times T will be 12 times 30 will give us 360. So we plug everything in. Now here's where I tell my students how to use the inverse key. Okay, so here's how we're going to put it in the calculator with a steady flow. So we're going to enter the numerator how it is in your calculator, right? Just the numerator. And make sure that you plug it in like that, guys, right? So then after you enter that, you're going to get something like 0.689043691 on your screen. Then you're going to press on the division key. After you press that, this is what you should see on your screen. Then you're going to enter 0.00325 and then enter it, and this is what you should see on your screen. 212.0134431. Then you're going to hit the inverse key, right? Because it's like multiplying by the inverse. You're going to use the inverse key. And then you're going to enter, this is what you see on your screen. Then you're going to enter the 325,000. And this is what you should see on your screen. The inverse key, guys, is very useful. When this way you cannot stop the calculator. It's like a steady flow. It's like whatever I got here, I'm going to multiply by the inverse of both sides. And this means that like it's going to be division over here on the left side. But anyway, right, so the answer will be, these are the payments that you'll be making every month, $1,532.92. Okay, now, how much money did you end up paying at the end of 30 years? So we had 360 payments of $1,532.92. So we multiply those. It's going to give us $551,851.20. So that's how much you end up paying for the house. So then, how much did you pay? So we subtract the 325,000 from the 551,851.20. It's going to give us $226,851.20. That's how much you end up paying extra. But you can eliminate all this extra interest by giving more money to the principal every month whenever you can. That's how you can avoid paying all that interest. Anyway, I believe this is it for this presentation. If you have any questions, please let me know. And I believe now you can download the PowerPoint. So you need to send me an email. You can just download it. And let me go back to the host.
Thank you so much, Mr. Isasi, for the wonderful presentation. We want to remind you all about our previously recorded sessions, which are available on YouTube on the Tejano Virtual Events playlist. This session will also be available on that playlist later today. Also linked is a short survey to help us improve our Tejano Virtual Events sessions. Please take a few minutes to fill out that survey. Before you all leave, I want to share with you the Tejano Virtual Events flyer with the sessions that we will have next week. At 1 p.m. today, we will have STEM Fuerte with Dr. Jennifer Jameson. We will be back with Happy Math Hour next week at 11, where in Math 1314 we will be covering the linear and nonlinear systems, and Math 1324 we will cover the Exam 3 review. Our 1 p.m. session next week will be on APCC Writing Center with Vanessa Ziga. Thank you all for coming today. We hope that you have a lovely weekend. If you have any questions, please feel free to use the chat box on your mic. We hope to see everyone again for a Happy Math Hour next week. Goodbye.